continuing lesson 6, 7, similar figures. We look at workbook page 81, number 1. I'm going to change this up a little bit, looking at this again. Doing a problem like this, figuring out what you need to do, it's easier for you if you do a reflection and then a dilation and then a translation. That's going to make things a lot easier for you. On this problem, if you look, we are going to do a reflection across the y-axis to start out with. So reflection across the y-axis. We can then think about where that would put us at. If we're starting with A, B, C, D, we reflect across the y-axis. Just think about how far you were from the y-axis before, and you'll be just as far away now. So that'll be where that puts us when we do the reflection. Now, the question is about the dilation that I suggested. We just go ahead and do the dilation next. If you'll notice, these sides are 2 and 3. These sides are now 4 and 6. So we went from 2 and 3 to 4 and 6. You can see that's doubling our sides. So you can see then that would be a dilation with a scale factor of 2. So I'm going to go ahead and do that next. It's just going to make things easier. So A prime, we're at -4, -4. And so if we double that, that's going to be -8, -8. So -8, -8. B is at -4, -6. If we double, that's going to be at -8, -10. Okay. Really, we can just look at any one of our points. The A prime here needs to go to E. E is at -4, -2. So the question, if I do my dilation and I'm at -8, -8, how do I get to -4, -2? So I got kind of a mess going here, so I'm just going to do this on a different graph. We're at -8, -8, trying to get to -4, -2. So the book's telling us we're going to go right and up. The question is how many? Well, going from here to here, we'd have to go to the right 4 units. Would get us our x value to -4. And then we're going from -8 to -2. That would mean we'd be going up 6 units. Okay, so much easier this way, doing that dilation first and then doing our translation. Number 2, if triangle PQR were similar to triangle XYZ, what angle would correspond to angle Q? When it's talking about an angle that corresponds is like something that matches up with, okay? So when you see correspond, think matches up. And we talked a little bit about this. You know, if they do this PQR XYZ, the order we put those letters matters. So if we look at that, what position is Q in when they say PQR? It's in the second position. It's in the middle position, as there are 3 of these. Okay, so which letter is in the same position and the other one then would be Y. Good. So the angle that corresponds with angle Q would be angle Y then. Okay, and again, it's because it's in the same position in that statement that they're making. Middle position, we know those are the ones that match up. Okay, and then part B, they're asking if the triangles are similar. Well, we can look at this with our triangles. and we can make rectangles out of them. So if we make this into a rectangle, make this into a rectangle, actually wouldn't have to do that on this one because we already had two sides that are just straight sides. So if we look at this, just count the squares. So on the blue triangle, this is 2 squares, this is 4 squares. On the red triangle, this is 3, and this is 6. In order for these to be similar, the sides that match up with each other have to be proportional. So, you know, this one's kind of obvious maybe. Obviously the smaller side has to match with the smaller side, bigger side with the bigger side. If it was something a little bit more crazy, it's more difficult for us to tell what's happening. Again, you can go back to the statement here and look at the order. So for example, PQ and XY are in the same spots, would match up. PQ and XY. So PQ is 4, XY is 6. Okay, and again, I know that's just the longest two sides, so on this problem it's not a big deal to say that. So the 4 matches up with the 6. If we look back at our statement, the QR and the YZ should match up as well, which is 2 to 3. And again, these need to be equivalent to each other if these are similar. So this one, the fractions are not identical right now, but the 4, 6, if you'll notice, we can reduce both of those by 2, would be 2/3. Obviously 2/3 equals 2/3 once we get it to that point. And so the question was whether these are similar, and the answer would be yes. And we could just say, for an explanation, we could say the sides are proportional. Okay, it's not being stretched just one direction or the other, but proportionally being enlarged here. Number 3, we have quadrilateral RSTU. It's translated 6 units to the right, 4 units up, dilated with the center of dilation 0, 0, scale factor of 1/2. They want us to graph the resulting similar quadrilateral VXYZ. So they're changing the letters up on us here, so we'll have to watch with that. So just a couple things at a time. If you want to do both your translations at the same time, that's fine. We're going to go 6 to the right and 4 up. So we take point T, for example. 6 to the right would take us to -2, and up 4 would take us to -2. So that's going to be, I'm going to call it T prime because we moved point T. S is at -16, so 6 to the right would be -10, and 4 up. Okay, and it should be in line with T if we did that correctly. Okay, and again, we're just translating it right now. We're just moving the points, so it should stay the same size that it was before. Alright, so if we do both of our translations, we should be at this point, if I did that correctly. And then the next thing is we're going to do a scale factor of 1/2. Well, scale factor 1/2, that's doing a dilation. Remember, dilation can make something bigger or smaller. In this case, scale factor of 1/2 is going to make it smaller. Good. It's going to make it half as big as what it was before. So for this, probably the easiest way would be, let's go ahead and list what our coordinates are for these points. Because remember, we're going to be multiplying our coordinates by something, by our scale factor. Yes. When we talk about scale factor, it's always multiplying. Good question. Okay, so in this case, we're just going to take each of those and we're going to be multiplying them, the x's and the y's, by 1/2. And understand, multiplying by 1/2, it's the same as dividing by 2. So that would be another way you could do that. And another thing, just to make things interesting, they changed letters here. So RSTU is going to VXYZ. So watch that as well when you do your dilation here. So if we take our first point here was R, and it's going to go to a V. So we were at R prime is -10, -10. If we take half of both of those, half of -10 would be -5. So that's going to take us to -5, -5. We'll do this in blue here to distinguish it. That's going to be V S. If we take half of both of our S primes, that's going to be -5, -1. And that's going to be X. And then T, take half of both of those, would be -1, -1. That's going to be Y. And then half of -2, -10, that would be -1, -5, and that would be Z. So when we do that, when we do dilation, remember it should be proportional, so looks like it is going to be still similar, which is what we wanted to happen. So that would be our new quadrilateral there. Number 5, we have a quadrilateral RSTU that is similar to quadrilateral VXYZ. And first question, which angle corresponds to angle S? So on that, to see which one it corresponds with, we'll just look at our order of how they listed the letters. So S is the second letter here, should match with the second letter here, is what it's going to correspond with. So that would be angle X that it corresponds with. And then if you look at B, it says describe a sequence of transformations that shows these are similar. Again, this is kind of a little bit difficult deal to actually do that, but we could talk about otherwise. We could prove that they are similar. You know, it'd be a reflection, and then actually this one's not too bad. This would be a reflection and then a dilation by a scale factor of 3. We could get it. But just in general, again, to prove that these are similar, we could count squares. So this one, we've got 2 sides that are straight. So this is 6 and 6. Over here we've got 2 and 2. If we extend this out to a rectangle altogether, this would be 3 more, would be 9. And this would be 9. Over here, if we extend this out, this would be 3 and 3. Okay, and so you can see with all those numbers, basically if you multiply the 1 by 3, one number on the red quadrilateral by 3, that'll get you to the number on the blue quadrilateral. And just thinking back on it now, back to the first problem we did on number 1, that would have been a good step, I guess. If we would have done something like this, that would have told us what our scale factor would have been. Does that make sense? Figure out what scale factor you'd need, and then that would have helped us to figure out where we would have needed to move the points in order to figure out how much we translated, you know, left, right, up, down to get that to work out. So this gives you an idea about similar figures.